Hi everyone, and welcome to this video, which is just going to be a short review of everything that we've covered in Year 8 equations and algebra. What I'm going to be doing in this video is I've just written a few sample questions from different algebra topics, including simplifying expressions, expanding expressions, factorizing expressions, and so on, and then also some questions on equations in which I'm solving various equations, some of them starting off a bit easy, but then going to some harder equations where they might involve brackets or pronumerals on both sides, with some quadratic equations at the end as well. So the idea is, as you're watching this, you might have a crack at the question yourself, maybe pause the video so you can have a go at doing the question with a piece of paper in front of you. Then once you've had a go at the question, you can then watch my solution and then see how you go with it. So let's just get right into it. So this first slide is on simplifying. This is just, you have this algebraic expressions with a bunch of different terms, and we want to simplify it. We basically want to write it in a shorter version. Now, as you notice that these are all addition and subtraction, and the golden rule with adding and subtracting algebraic terms is you can only add and subtract the like terms. You can only add and subtract the things that have the same letters. Exact same letters. Starting off with this first one, we see that we have x's. So let's focus on the x's first. We have 5x and 2x. Okay? And we also need to look at the sign that's sitting in front of it. So we're not going to do 5 minus 2x or whatever. We're going to do 5 plus 2x. So 5 plus 2 is 7. So 5x plus 2x equals 7x. Do not make it x squared. Just because there's two x's does not mean we combine them to be x squared. That's what we do in multiplication, but in addition, you just keep it like that. And then same with the y's. So we have 3y plus 4y, that equals 7y. So there we go. We have 7x plus 7y, and you cannot go ahead and say, and that equals 14xy, because like we said, they are not like terms. One has an x, one has a y. They're like not compatible. They're different fruits. I know lots of people thinking they're different fruits. Those fruits do not mix together. Looking at this other question, you'll see that there are a bunch of x's and x squares, but there's you need to realize that some of them are x squared and some of them are x. So because of that, you might as well make them different letters at that point. You see that we've got the 7x, we have plus 5x, we have plus 2x. But we're going to ignore the x squared there for a second. So we do 7 plus 5, which equals 12. 12 plus 2, which equals 14. So we have 14x. And now we're going to look at the x squares. And it's just that. So we're just going to keep that minus 4x squared. It doesn't magically become a plus or anything like that. And again, what we're not going to do now is do 14 minus 4, so that's 10. Because again, they're not like terms. One of them is x, one of them is x squares. They might as well be different letters at that point. So that's just some basic simplifying. Going on to the next slide, we're going to be talking about expanding. And expanding is when we have a set of brackets and we want to write it outside the brackets. Okay, we want to write these things without brackets, but we need to make sure they're the same. So what we can't do in this first question, for instance, be like, oh yeah, that's 4a minus 3. Just get rid of the brackets. We need to make sure that mathematically it's still staying the same. The way we do this, you might remember, is we get that number that's out the front, we multiply it by everything that's inside it, one at a time. So what we're going to do is we're going to do 4 times a first, which is 4a, and then we're going to do 4 times negative 3. Now, 4 times 3 we know is 12, so if we're doing 4 times negative 3, it's negative 12. So basically, you can kind of think of it as two mini questions. First doing 4 times a, which is 4a, and then 4 times negative 3, which is negative 12. And put those two answers kind of next to each other. So going into this next question, the exact same thing. We're just going to get this negative 2. We're going to multiply it by 5. So negative 2 times 5 is negative 10. Make sure you're looking up for those negatives. And then this next question, this next part to it, we're also going to do negative 2 times negative 3. Now remember, negative times a negative equals a positive, so we're going to have plus 6, and of course don't forget the x as well. So we have negative 10 plus 6x. Okay, you don't want to, just because there's a minus inside the bracket, doesn't mean there's going to be a minus in front of the x at the end. Right? If we multiply by a negative, it becomes a positive. And on this last one, what we're going to do is, again, we'll just expand it to start off with. So 2a times b equals 2ab, and 2a times 2a equals 4a squared, and then we also have that plus 5ba at the end. Although we're not changing that, we're not multiplying it by 2a, because we see that 5ba is kind of disconnected from the bracket. So we're just going to put plus 5ba at the end. But then we can simplify this, even though it might not look immediately obvious. We see that here, that is 2ab, and that's 5ba. Even though that the letters are the wrong way round, one of them is AB, the other one is BA, they both have the exact same letters, and they don't have different powers or anything, so they are still like terms. So 2 plus 5 equals 7. We're going to say 7ab plus 4a squared, and that is your answer. Again, like I said in the previous slide, we can't combine them because one of them has AB and the other one has 2a, it's a squared. Going into factorizing, so factorizing is essentially the opposite of expanding. Where with expanding we have the brackets and we want to write without the brackets, factorizing is we don't have the brackets and we want to put it in brackets. So what we need to do, as the name suggests, is we want to find the highest common factor. Alright, hence why it's called factorizing. So looking at this first question, we need to think of what number can I divide both 3 and 9 by. So we can divide 3 by 3 and can divide 9 by 3. So our common factor is 3. And I can't take out the x because there's an x on that first one, but there's no x on the second one. So we're just going to open the bracket now. So when we do 3x divided by 3, we're just left with the x. And when we do 9 divided by 3, we're going to be left with just plus 3. And the way that you can check to see if your answer is correct is, since I just said factorizing and expanding are opposites, what I can do is, if I just expand this again, if I do that, I'll get 3x. If I do 3 times 3, it gives me 9. What I should end up with is the thing that I just started with. And as you can see there, I started with 3x plus 9, I ended up with 3x plus 3, which gives me, when I expand it again, 3x plus 9. That's a way that if you, in your test, you can actually check to see if your answer's right. So going into this next question, again, we want to look at 24 and 16. Now 24 and 16 actually have quite a few common factors. They can both be divided by 2, they can be divided by 4, and they can also be divided by 8. What we're going to do is we want to get the highest common factor. So thinking about 2, 4, and 8, 8 is the highest common factor because they can both be divided by 8. So we're going to write that 8 out the front again. And now when we do 24 divided by 8, that gives me 3. When I do negative 16 divided by 8, it's going to give you negative 2. And again, that g is still there, so we've got to write the g. Now, of course, if we expand to that, 8 times 3 is 24. 8 times negative 2 is negative 16. Put the g there, so that's how we check to see if our answer is right. Lastly, in this question, we focus on the numbers first. So the common factor of 7 and 14 is 7. But we also notice that there's also a common letter as well. You see in that first term, there's 2 a's. That's what a squared means. It kind of means like AA. And then we see that there's AB in the other one. So that means each of them have one A. So I'm going to take out an A as well. Now, I've got no more common factors. So once I've taken out 7 and an A, I'm only left with another A. Okay, because you need to remember that A squared basically means AA. So if I've taken out one A, there's still an A left over. And then so if we have, and that's it. So now we're going to do 14 divided by 7, which equals 2. We've already taken out the A, leaving me with just the B left over. And then that's it. Again, expand to see if you get it right. So that's it for the algebra side of it. Now I just want to spend a bit more time going into equations. I'm going to try and make this fairly quickly because, as we know, the way that we solve equations is it's always the same thing. You look at what you have and you do the opposite. So what that means is, in these equations, when we're solving an equation, we're trying to find what number makes that equation true. The easiest way to do that is to move all the numbers to one side, so you're just left with the pronumeral, the thing you're trying to find, by itself on one side. So here we have a plus 3, and that equals 10. So what we need to think of is, well, what's the opposite of plus 3? The opposite of plus 3 is minus 3. And if I'm going to minus 3 on one side, I need a minus 3 on the other side as well. So by doing that, 3's cancel out, leaving me with just a, and 10 minus 3 equals 7. And that's my answer. Now, you look at that question, you probably think, well, obviously, if I'm trying to figure out a number plus 3 equals 10, of course it's 7. Yeah, that's right. I mean, it is a pretty easy one. But some of the other equations we're going to get to shortly, they're not as easy. So this is why we need to learn these systematic ways of doing the inverse operations, doing the opposite of what you have to find the answer. So here we have x over 2. And fractions are just another way of writing division. So this is essentially saying x divided by 2. Now the opposite of divide by 2 is times by 2. The opposite of division is multiplication. The opposite of addition is subtraction. And they both go reverse. So what we're going to do here to get rid of this divide by 2 is going to times by 2 times by 2. So by doing that, they cancel out. X equals 11 times 2, which equals 22. And there's my answer. Going down to this question now, we have negative 5 times x. So it might look like a minus and you think, oh, we're going to plus here. But you need to think about what this is actually saying. This negative 5x means negative 5 times x. And as we just said, the opposite of division is multiplication. So that means the opposite of multiplication is division. So what we're going to do here is we're going to divide by negative 5 and divide by negative 5. So when we do negative 5 divided by negative 5, they go away. So we get x equals, and 25 divided by negative 5. Well, as we know, 25 divided by 5 is 5. So if we divide by negative 5, we're going to get negative 5 as our answer. And then lastly, looking at this question, here we've got 9 minus a. I realize my a, that a kind of looks like a 9, but you've got to bear with me. That's 9 minus a equals 5. Now again, you might be able to look at that question and well, it's obviously 4. But let's go through it properly anyway. So what we have here, you kind of got to imagine that there's an imaginary plus sign there. And the opposite of plus is minus. So we minus 9, it equals negative a equals 5 minus 9 equals negative 4. So now that we've got that, we've got negative a, but we don't care what negative a is. We want to find out what positive a is. So we want to get rid of that minus sign as well. What you can do is just realize, oh, if that's a negative, then I'm just going to get the positive version and get rid of a negative sign. But that's what we can do instead to make it follow our rules a little bit better, is that's essentially saying negative 1 times a. So the opposite of negative 1 times is we're going to divide. So we're going to divide by negative 1, divide by negative 1. So if we have a, negative 4 divided by negative 1, well 4 divided by 1 is just 4, and if they're both negatives, the negatives go away, so we get a equals 4. Like we said, was going to be the answer right at the start. Going into our next questions now, so we have a couple of two-step equations, where we see now there's actually two things that we need to get rid of. Looking at this first question, we have a 5 and a 6. We want to get rid of them both, so we can get the answer. So the easiest way to do these kind of two-step equations or any type of equations is you want to generally get rid of the numbers that are furthest away from the x. So we see that we have this 5 and we have this minus 6, and we need to think about, well, which one's furthest away from the x? Because that's generally the easiest thing to get rid of first. So here, in this case, the thing that's furthest away from the x is the negative 6. And so the opposite of negative 6 is going to plus 6, and that gets rid of the 6. So we now have 5x equals 30. And now that we have that, again, that's saying 5 times x. the opposite of times is divide. So divide by 5, divide by 5. So we have x equals 30, divide by 5 equals 6, and that's my answer. Now something I haven't really talked about in this video yet, but the way that you can check to see if your answer is right is just substitute your answer, x equals 6, back into the question and see if it's right. So if we make, in here, if we do 5 times 6 minus 6, well 5 times 6 equals 30, and 30 minus 6 equals 24, and that's what we expected to find. So because it equals 24, and that's the kind of goal we're trying to achieve here, that means we know our answer is right. So when you're in your test, you can basically mark yourself if you wanted to. Just substitute your answer in and see if it gives you that right answer. So that's a little tip there. And then looking at this question now, we have a minus 4 over 2 equals a. Again, we've got to get rid of the negative 4 and the 2, and we need to decide which one's further away. In this case, the 2 is further away. So the opposite of divide by 2 is times by 2. So we're going to times 2 on both sides. The 2 is going to cancel out, leaving me with a minus 4 equals 16. And then from there, the opposite of minus 4 is plus 4, so a equals 20. And again, there's our answer. So that's two-step equations. So now what we're going to do is do a few trickier equations, where first of all, if we have pronumerals on both sides. So what we have here, looking at this first question, is we see that the a is on the left side and the right side. And that's a problem, because when we're solving equations, as you just saw, we want to get the a's on one side and all the numbers on the other side. So what we'll do is we need to move all the a's to one side first of all. So what I generally do is, if I have them on both sides, I'm going to look at the thing that's on the right and I'm going to move it to the left. So in this case, I've got that 7a and I want to move it to the other side. Again, that's kind of like an imaginary plus 7a. So the opposite of plus 7a is minus 7a. And when I subtract that, I've got to subtract on this side as well. So 8a minus 7a equals 1a. But as we know, 1a can just be written as a. It just gives me a. Now, we don't do 3 minus 7, negative 3 minus 7 as well, because again, they're not like terms. Okay, we can only add and subtract like terms. So we're just going to keep that minus 3, and that just equals to 5, because again, that cancelled out. So we just got that. And now that's an easy equation to solve. The opposite of minus 3 is plus 3, plus 3. So we have a equals 8. And again, we can sub our number in to check to see if our answer is right. Going on to this one down here. Again, we have a's on both sides, and I don't want that. So the opposite of minus 3a is plus 3a. I'm going to add 3a on both sides. So 2a plus 3a equals 5a, and equals 4 equals 14. So what we've done there again is we just did 2a plus 3a equals 5a. Again, it's not 5a squared. When you're adding the terms, you do not change the letter. And now we need to get rid of that 4. So we have 5a equals 10. And then we'll divide by 5, divide by 5. A equals 2. And there's our answer. So I'm hoping that after these few equations, you're starting to see that basically all the equations follow the same rule. You just look at what you have and you do the opposite. You do your inverse operation to make A the subject, make A the answer. So just 2 more slides. We've got these equations with brackets. So when we have equations with brackets now, you might remember back when we were doing expanding, when we had the brackets, we needed to multiply the thing out the front with everything inside. Well, this is just the same thing. We're going to do that, but then solve an equation afterwards. So looking at that first one, if we do 2 times x, that equals 2x. If we do 2 times 5, that equals 10. And now we just have a 2-step equation. We now need to think, well, should we get rid of the 2 or the 10 first? We should get rid of the 10 first because it's further away. So we're going to minus 10, we get 2x. 16 minus 10 equals 6. And we divide by 2, x equals 2, 3. And there's your answer. Again, to check to see if your answer's right, if I put 3 into this, so if I did 2 times 3 plus 5, or 3 plus 5 equals 8, and 2 times 8 equals 16. So, and that's what we were expecting in that question. So we know we're right. And this last one, this is kind of like a combination of the equations of both the equations with pronumerals on both sides, and also equations with brackets. What we need to do here is we're going to expand both sides. So we're going to do 5 times a, we get 5a. We do 5 times 4, that equals 20. We're going to do 3 times a, that equals 3a. We're going to do 3 times 2, that equals 6. And now we have a's on both sides. So what I want to do is I want to minus that 3a, minus 3a. So I can get them to one side. So now I have 2a plus 20 equals 6. The next thing I want to do is get rid of either the 2 or the 20 and get rid of the thing that's furthest away. So minus 20, minus 20. So we have 2a equals 6 minus 20 is negative 14. And then lastly, when we divide by 2, a equals negative 7. Again, remembering the negative because we're doing negative 14 divided by 2. So 14 divided by 2 is 7. So negative 14 divided by 2 is negative 7. One last slide. So we're going to quickly talk about quadratic equations. And these are just simple quadratic equations. When you get into like year 9, year 10, and even year 11 and 12, if you want to do advanced in year 11 and 12, we're going to be talking about much harder quadratic equations. But for now, these are just some simple quadratic equations. And we have x squared equals 9. So what we want to do here is we want to get rid of squared. And remember, squared means you're multiplying a number by itself. So the opposite of squaring a number is square rooting a number. So that's that symbol. So here, if I want to square root both sides, we're going to have x equals, the square root of 9 is 3. But one thing we must also remember as well is if we're going to do the square root of 9 when we're solving an equation, we also need to consider the negative answer as well. What we're saying here is that there are two numbers that we can multiply by itself to equal 9. If we do 3 times 3, yes, that equals 9, but we could also do negative 3 times negative 3, which equals positive 9 as well, because we're multiplying two negative numbers together to make it positive. A quicker way of us writing this is writing x equals plus minus 3. That's just me saying x can equal either be positive 3 or negative 3, it doesn't matter. It fits that equation. So quadratic equations have the special property that they sometimes give two answers rather than just one answer. In this case, the two answers are 3 or negative 3. And that's how you do quadratic equations. So here, again, we want to, this is a two-step equation, the second question. We want to get rid of the squared, and we also want to get rid of the negative 5. Again, following our basic rule of get rid of the thing that's furthest away, first of all. So the thing that's furthest away here is minus 5, so I'm going to plus 5, leaving me with x squared equals 16. And then you're going to square root both sides. So we're going to have x equals plus minus 4. Again, don't forget about the plus minus, because there are actually two answers. If in your test you just wrote 4 and forgot the negative 4, you won't get the full marks, okay? Because you need to acknowledge that there are two answers to that equation. Anyway, this is just the end of the video now. So just covered a few things on algebra and equations. Hopefully this will be useful for your revision for your test, or just if you ever need to catch up on your algebra and equation skills. But this is the basics of it all. Just talking about simplifying, expanding, factorizing, and solving basic equations where you just do your inverse operations, always getting rid of the thing that's furthest away from the x or the a or whatever letter you have first. Anyway, hopefully this has been helpful, and if you have any questions, make sure you ask. And of course, this being a video, if you ever stuck on something, come back and watch it again, or rewatch it and rewatch it and rewatch it. Anyway, good luck with your test.